Hello friends, let me solve this last example on this topic. This is the dynamic viscosity of an oil used for lubrication between a shaft and sleeve is 6 poise. The shaft is of diameter 0.4 meter and rotates at 190 revolutions per minute. Calculate the power lost in the bearing for a sleeve length of 90 millimeter. The thickness of oil is 1.5 millimeter. So this is the shaft and this is sleeve. This thickness is 90 millimeter and this is 1.5 millimeter thickness. In this portion there is oil. So thickness of oil is 1.5 millimeter. We have to find power loss. You all knows power equals to force into velocity. But if we talk about angular velocity, we can write power equals to this force is here torque. I will write T, and velocity is angular velocity, that is omega. So I have to find this power lost. I have to find torque into this omega. So let we start. How can we find this? We can find this easily. If we find this tau, this is force per unit area. So I can find force from this because I know area of this sleeve. So I can find force from this, and with the help of force I can find this tau, because tau equals to, this is torque equals to force into this perpendicular arm, that is diameter by 2. So that will be diameter by 2. So I have to find first tau. So let me start. We know tau equals to mu into du by ty. Here I will write du. I will write dy. Dy is 1 point. Here ty is 1.5 millimeter. So I can write 1.5 into 10 power minus 3 meter. And mu is given 6 poise. You already know this will be 6 divided by 10 in SI units. So I will write 0.6. Mu is 0.6. And now I have to find this du, which is relative velocity. You all knows velocity is distance traveled by time taken. So what is the distance? This is in one revolution it travels distance which will be equal to this perimeter, or we can see which will be equal to the circumference, that is 2 pi r. We can write pi d. It will travel pi d distance in one revolution. So it is making 190 revolutions. I will write here 190, but it is taking time to, 1 minute, because it is making 190 revolutions per minute. So time is 1 minute, which is 60 seconds, which comes out to be which is 3.97 meter per second approximately. So now I can find tau equals to mu is 0.6 into velocity is 3.97 by this relative distance, which is 1.5 into 10 power minus 3. So which comes out to be it will come 1590.93. Now tau is, which further implies tau is 1590.93. Now I have to find force. I know tau equals to force per unit area. So I will write force per unit area. Area is circumference of this circumference of this circle into length. Circumference is pi d and length is, so So I will write pi d into length is 90 meters. This is 90 millimeters, so I can write 90 into 10 power minus 3 meter, which is equal to 1590.93. so which further implies force will be 1590.93 into pi d into 90 into 10 power minus 3. So which will come, I will write here in place of 10 power minus 3 I will take this point here. So I will write 1.590 into 3.14 into diameter is 0.4 into 90, which further implies force will come 179.73 Newton. Force will come approximately 179.73 Newton. Now I can find this power lost easily. So power will be this tau. Tau is, this is torque. Torque is this force into this diameter by 2, because this is perpendicular arm. So tau will be force acting here into this radius. So tau, I will write torque into omega, which further implies torque equals to force is 179.73 into this diameter by 2, that is 0.2 into omega. Now we will find omega here. Omega is this angular velocity, which is angular displacement. I will write here theta by time taken, which will be equal to, in one revolution it completes 2 pi angular displacement, and it is making 190 revolutions. I will write here 190, and it takes time 1 minute. So I will write here 60 seconds. So which comes out to be 19.88. So I will write here 19.88. So therefore power lost will be equal to this into 0.2 into 179.73. This will be 714.84 watt. So this is the power lost. Power loss is 714.84 watt. Hope you understood this. Thanks. Have a nice day.